Elon Musk's SpaceX successfully achieved the landmark technical feat of being the first privately owned company to deliver human beings to the International Space Station on one of its celebrated Falcon 9 rockets. Experts reckon this marks the start of what could be a golden age of space exploration, as independent actors, free from the shackles of unpredictable public finances or whims of whoever happened to win the last election, can accelerate mankind's long-promised progress out into the stars. But how did SpaceX actually do it? Through brilliant engineering know-how, of course, and a cost-conscious, business-minded strategy. So today we're examining the question, how does SpaceX build their rockets? New technology is, of course, central to the SpaceX brand, and there's been no shortage of groundbreaking innovations coming out of its workshops. Since 2014, for instance, hypersonic grid fins made of titanium have been installed on all SpaceX rockets to facilitate those trademark smooth and, above all, precise landings. These are typically arranged in an X-shaped configuration, and according to Elon Musk, will be manufactured from welded steel on future Starship vehicles, owing to sheer size constraints. A range of supplementary technologies to control the altitude of rockets has also been developed by SpaceX. These are crucial for the landing stage of each mission, and therefore the reusability of its rockets, and of course from there the overall economic viability of the program. One of the main problems engineers needed to overcome early on was unwelcome spinning on descent, which caused fuel to slosh around in a centrifugal motion, causing catastrophic engine failures. Cold gas thrusters near the top helped stabilize and flip the rocket around so it maintains its upright position. And although not directly related to the rockets themselves, a small fleet of autonomous ocean-going landing platforms have also been developed by SpaceX to support touchdowns at sea. Musk has named these, with characteristic brio, "Of course I still love you, just read the instructions," and, coming soon, a shortfall of gravitas. Landing gear, in the form of nested carbon fiber and aluminium extendable landing legs, are another innovation developed by SpaceX, with high-pressure helium chosen as the lightweight working fluid to assist deployment. These legs also incorporate what's known as a crush core in order to better absorb the shock of hard landings. But aside from all this shiny new tech, more on which later, the financial side of the SpaceX operation is just as important and fascinating in its own way. Remember, SpaceX was founded in 2002 when Elon Musk, flush with cash from the sale of his PayPal empire to eBay, set out to try and establish a colony on Mars, specifically by bringing down the cost of rocket launches. That cost element might sound drab, but it's very significant. Because although state actors had previously made great gains in space exploration, the Soviets putting Yuri Gagarin in orbit, for instance, or the Americans landing Neil Armstrong on the moon, they'd done so by essentially handing their scientists and engineers a blank checkbook. Elon Musk, on the other hand, believed that approach to be foolhardy and wasteful. And he's been determined to make space travel not only possible, but also to make it pay for itself. And so far, he's doing pretty well with that. Never shy of bragging about his accomplishments on Twitter, Musk recently noted that last time he checked, it cost over $1 million less to ensure a Falcon 9 mission compared with his rivals. Why? Let's look at the numbers. This summer, SpaceX Director of Vehicle Integration, Christopher Koulouris, stated that it costs around $28 million to launch a Falcon 9 rocket, and that with everything. Compare that to an April 2020 report on CNBC suggesting a United States Air Force launch costs about $95 million. If drab cost saving is the driving philosophy behind SpaceX, then reusability is the practical means by which they go about achieving it. Just a couple of months ago, a Falcon 9 rocket completed its 7th successful flight. Each flight was interspersed with one of the vertical landings that SpaceX have somehow made into a routine, even humdrum feature of rocket launches. Elon Musk once blankly stated he felt it was absurd that aerospace giants Lockheed and Boeing don't sell single-use aircraft, but only sell single-use rockets, and a modern jet airliner, which can take off and land thousands of times, costs about the same as a Falcon 9 rocket. The Falcon 9s are constructed at SpaceX's sprawling headquarters in Hawthorne, a suburb of Los Angeles in California. As you might expect, security is tight, so not a great deal is known about what goes on inside. Out front, like a tourist attraction you might see at a film lot up the road in Hollywood, is a Falcon 9 rocket. In fact, the first to successfully launch and land. They're very proud of it. Inside Hawthorne, which incidentally used to be a facility for building Boeing 747 fuselages, SpaceX operate on what's known as a vertical integration model. This means the vast majority of components, engines, rocket stages, avionics, and software are all made in-house. This saves costs and helps speed up production to the point they can manufacture a whole rocket in a little under 2 weeks. How? By not relying on external suppliers who can unpredictably create delays or competing priorities, SpaceX can streamline the process. The design of the rocket itself is also packed with interesting and innovative subtleties that help its core mission of reusability, while at the same time being easier and cheaper to assemble. For one, the arrangement of the Merlin rocket engines. Earlier versions of the Falcon 9 had 9 engines arranged in 3 rows of 3, but a lighter, more elegant solution was discovered at Hawthorne, and now 8 are arranged in a circle around a central Merlin booster. This uses less materials and is therefore cheaper. Another brilliant engineering innovation concerns the so-called interstage of the Falcon 9. When the first stage has lifted the payload into orbit, traditionally the second stage blasts clear using an elaborate pyrotechnic system of exploding bolts. On Falcon 9, however, a less intensive pneumatic system was developed, saving weight and vital energy. SpaceX launches, using rocket parts manufactured in Hawthorne and assembled near the launch site in Florida, are becoming almost commonplace. But Elon Musk's company isn't stopping there. Recently, they've also taken over a large area of coastal land in southern Texas around the sleepy town of Boca Chica. There, the next generation of SpaceX craft are taking shape, and their ambition really is to go all the way to Mars as soon as this decade. Again, specific details of what's happening inside Boca Chica are sketchy, but what is known is that the new Mars-bound craft, known as Starship, is taking shape fast, with around 1 full prototype a month emerging from the workshops. Musk's ultimate vision is for his Boca Chica shipyard to become the first commercial Cape Canaveral, helped in no small part by its location near the equator. Here, the accelerated spin of the Earth assists with launches. Not content with hopefully colonizing our interplanetary neighbors, Starship will also be even better than Falcon 9 at what's rapidly becoming the bread and butter of SpaceX business. That is, delivering satellites into orbit as part of SpaceX's internet broadcast project Starlink. It's said that Starship will be able to deliver more satellites more cheaply than anything currently on the launch pad, which in turn will generate revenue for the company's future rocket-building exploits. Which brings us nicely back to our original question. Because unlike Elon Musk's bitter rival for space supremacy, Jeff Bezos, a man for whom cost isn't really an object, SpaceX is always thinking about that all-important bottom line. So how does SpaceX build their rockets? As cost-effectively as possible. So Elon Musk can go on making even better rockets and having a blast as he does it.